very large and baroque language. And that's not at all how I would design a language, but it's a valid architectural decision. It's a good purge. And so I'm not going to criticize that. But being a large and baroque language has some consequences that need to be addressed. And there are problems in that aspect of it. So with a large language, you have, let's say we have n language features. And that means that there are n squared sets of feature interactions. And in a language design, you always have to manage the feature interactions. Every interaction, each of those n squared interactions, is an opportunity for bugs to creep in. And if you're not careful, then a significant fraction of those opportunities will turn out to be buggy. And that is what we see in Perl 6. So I'm going to show you a couple of examples. I'm using Rakudo on MoreVN, and this is up to date as of yesterday. I don't think everything's been fixed since then. So let's look at two language features. Here's one language feature. This is a type-constrained variable. And the type constraint means I can assign an integer to it. I cannot assign a string to it. Okay. Now, here's a second language feature. There are special objects such as core. Core is a module object. This is quite a special kind of object. And now let's put those two features together. Assign core to the type constraint variable, and I'm allowed to do it. If we just look here, we see that indeed the module object has been stored in this type constraint variable. The module object is not an integer. The type constraint just isn't being applied. So that's a buggy interaction of features. And just very quickly, here's another buggy interaction. What's going on here? Well, there are essentially two ways in designing language that you could manage feature interactions. One approach is to keep n very low, to absolutely minimize the number of features so that you can keep all possible interactions in your head and manage those and avoid bad interactions by sheer skill. But for a larger language, you can't do it. Perl 6 is far too large for it. The n squared is way beyond any human mental capacity. So the only other option is you have to keep track explicitly of what features you have and go through every one of the n squared interactions explicitly and keep notes about how those interactions ought to behave. Each of those n squared interactions really ought to become a bunch of test cases in the test suite. But in Perl 6, it isn't that way. We don't have systematic tests like that. The n squared interactions have essentially not had that kind of explicit thought put in them. And so a certain proportion are buggy. These two examples, it doesn't, the purpose of me showing these examples is not particularly to call out these particular ones. These are not of great significance. The point is that they are part of a large class of buggy interactions. I wanted to show you some examples, and I had several lined up. And then yesterday, I ran into these two, and that's why I'm showing you these ones, just by accident. I wasn't particularly looking for new ones. And so that illustrates that not only are there buggy interactions of this kind, but there are a lot of them, and there are a lot remaining to be discovered. The immediate effect of this is that the Rakudo Christmas release is going to be a lemon. We can fix the particular bugs in most cases, but retrospectively, we're going to look back on Rakudo Christmas the same way that we look back on Perl 5.6.0. It's going to be the bastard release that no one wants to support because it's riddled with bugs and you can't avoid running into them. Of course, that's an inherent risk of releasing at a prescribed time. Rakudo just isn't ready. But there's more of a problem here than than just bugs in the implementation. Some of the bugs simply are in the implementation, these ones probably are, but there are other bugs that arise just from the nature of the language design and need to be addressed at a language design level. And the result is that not only does Rakudo have order n squared bugs, but the language specification also has order n squared bugs. It's a small order n squared, but it's still a large order. So I'll now show you a bad interaction that is firmly in the realm of language design. So here I'm going to look at the call symbol table, not the module object. I'm going to extract the names of symbols. I'm going to select just the ones that end with D, sort for consistency, and how many are there? There are 24. Great. Now, let's do a map. For each of those names in the symbol table, I'm going to extract the value that is stored in the symbol table for it. And how many of those are there? 17. Something's gone wrong. What's happening is that the 18th name is iteration end. And the value that is stored under that name has special use as a sentinel in the iterator API. And it turns out that when you return this from a map function, it has the effect of terminating the map early. This is inconvenient. Now, when I actually reported this, the reaction of the Perl 6 developers was to add this note into the documentation of the iterator API. So the only values of this sentinel is in the iterator API, and anything else is unsupported. Now, that kind of restriction is fine in certain kinds of programming language. It's fine if you only write substantive programs. If you only have to deal with numbers and characters and so on. But Perl 6 is very much intended to be its own meta-language. It is intended to support introspection and meta-programming. And so I've written a perfectly innocent bit of introspective code, and this kind of thing is supposed to be supported. This code doesn't intentionally use iteration end. It just encounters iteration end as data in the environment. If anything is abusing iteration end here, it's whatever constructed that call symbol table, because publishing the iteration end value in a public symbol table is clearly not this identity comparison as part of the iterator API. But it's ridiculous to say that that's buggy either, because the iteration end value has to be published in this kind of way in order to be used for its intended purpose. So that kind of restriction is totally at odds with the intent of Perl 6 to be used for introspection and metaprogram. As soon as you're using the language to push around programs rather than just data, you will run into this kind of problem, and this kind of restriction is not viable. So, on this point, this language definition conflicts with itself. So, I'll now look at another kind of awkward value that causes trouble with maps. Let me set up an array here, and now I'm going to put in the middle of that array a slightly awkward value, a slip. Now, a slip object is a kind of list. Slip is actually a subclass of list. So it's ostensibly is a lot less magical than iteration end. It's actually in the any class for those who know what that is. So I've got an array here of 3 elements, of which the middle one is a slip object. And the intent of the slip class is that in certain circumstances in iteration, a slip object will be unwrapped implicitly and interpolated into a surrounding list. And the direct result of that is that if I write a naive identity map expression like this, then the slip object gets interpolated, and I now have 4 items instead of 3. So this is not a correct identity map. Now, this behavior isn't a bug. This is totally intentional bit of design. But it's inconvenient. It means that if you want to to perform a map on arbitrary values, even just within the any class, then you have to work around this. You can work around it, fortunately. The way to do it is to wrap the slip, or in fact, everything you return from the map block, wrap it in an outer slip. And the outer slip protects the inner slip from this interpolation, because they're not interpolated recursively. So you pretty much need to do this. But actually that doesn't work either, because when the slip object is passed to this slip constructor, it gets interpolated at that point, when constructing the outer slip. So you can't do it that way. You have to use a much more roundabout way to construct your outer slip, which goes like this. This method of constructing a slip doesn't interpolate the inner slip, and so successfully passes through the inner slip. So this is a correct identity map operation. And that means this is the boilerplate that you have to start with if you want to perform any kind of transformation on values that are sufficiently arbitrary that they might contain slip objects.
Might I argue that assigning a slip to an element should be actually an error?
Well, if that gets changed, then some details of this would change, but slip objects that are still for the moment subclass of list. So, well, some of the details could change. So this is boilerplate which is required. And Perl 6 was meant to learn from Perl 5. We're meant to learn from its mistakes. We're meant to avoid the boilerplate that's necessary in Perl 5. We're meant to fix the Huffman code. This is bad Huffman coding. And another lesson from Perl 5 is that where this kind of boilerplate is required, a lot of programmers won't include it. They'll just write the naive expression and end up with code that has bugs. So this kind of system is detrimental to both the quality and the readability of code. This is a bad design. Perl 5 doesn't have this problem because of the unrarified way in which it handles lists, and that made it okay to overload a single map operator to handle returning both single values and lists of values to be concatenated. In Perl 6, those two uses conflict and really need to be separate map operators. It should have been rethought. So let's look at another bit of bad design. So there's a method called how. You can call on any object. I'm calling on an integer. And it returns a meta object. And there's another method called which identifies an object. Now here is an alternative way of calling a method. And it allows for interpolation to compute a method name, but I'm not doing it that way. So that just performs exactly the same method call. And if I do that with a how method, it doesn't work. Notice how not found, but it was found up there. So what's going on? Well, the reality is that this error message is correct. There is no how method. The .how syntax that I started with isn't a method call. The parser, when it sees what looks like a bare method call, checks the name of the method against a list of, there's a handful of magic method names. And if it sees one of those, then instead of compiling to a method call, it compiles to a built-in operator. So the syntax for those magical built-in operators is overlaid on, completely clashing with the syntax for an ordinary method call. And PHP has some operators that work that way, and it gets criticized all over for having such a syntactic clash. Surely we can do better than PHP. The syntactic clash is a problem. It is misleading. It misleads about what code is responsible for providing the behavior. It is useful that these special operators are provided in a built-in way that cannot be overridden by the class. But this confuses you as to which is which. And it's totally unnecessary. we're not short of syntax for this sort of thing. It's okay to have these kinds of magical operators be spelled with a letter-based name and to be made to look a bit like method calls. But you shouldn't make them look exactly like method calls. We've already got some other syntax like this, which is performing a method call on a class meta object. You could have done something similar to that for these magical operators. So that system's just not been well thought out. And I'll show you one more thing that's not well thought out. Here I'm creating a list, and I'm going to index it into it and attempt to bind into it. So binding is something you can do into indexable objects, but it's not actually valid to do it on a list. The structure of a list is immutable, so this is not valid. So there's going to be some kind of error. Now, the bind operation translates into a method call underneath. So obviously the list class doesn't implement that method, so you'd expect to get an error message along the lines of method not found, or possibly a better error message that refers to the high-level operation I was trying. But that's not what you get. You get a hang. So this is down to method delegation. There's a hugely complex structure of methods that do part of the work and delegate to each other or shift signature around. And what's going on here is that there's a helper method that picks up this operation, tries to do part of the work, and then delegate to the real method. But with the real method not existing, it ends up delegating to itself. So it calls itself in an infinite recursion. And because there's no proper tail recursion, this infinite recursion actually eats up memory. It will eventually fill it if I need it to go. And there are other things there are other method delegations that end up recursing in a similar kind of way. So this shows that structure of method delegations that looked so subtle seemed to be difficult to understand because it was clever and a whole wonderful cathedral of well-thought-out design. Actually, it's just hack-written. That's not being thought out at all. So, in this 20-minute slot, I've only been able to scratch the surface of the actual problems with Perl 6. I've shown you a handful of specific problems, but the point isn't really those specific problems. Each of those represents a large class of similar problems. And the overall problem that they all point to is that Perl 6 has no coherent design. It's an accretion of features that are individually okay, but interact badly. So, what can we do about it? Well, most of these specific problems can be fixed, some in the implementation, some in the language definition. But there's probably going to be a hardcore of interactions with language design implications that can't be fixed while maintaining an acceptable level of backward compatibility, which is a concern now. Even if you put backward compatibility concerns aside, this is the wrong way to go about building a coherent language. It's not good to have these bad feature interactions already ingrained in the language. Trying to fix it from there, that's the wrong way round. You need to address these interactions as features are put into the language. So we're doing it the wrong way around. And as a result, I think with regret that the Perl 6 language design is beyond redemption. I think the correct next step is for us to throw away the Perl 6 language definition and throw away its implementation Rakudo. But don't throw away everything we've got here, because there is some good stuff. Keep Morvia, that's cool. And keep NTP. And what we should do is to build something new on top of Morvia. We can build a new high-level language. We can, of course, borrow some specific ideas from Perl 6, but we've got to take some care about putting the features in, make sure they interact well and they become a coherent whole. And NQP is a useful vehicle in which to do this. NQP is a subset of Perl 6, but it avoids most of the crazy. It doesn't have these problems that I've pointed at. And by design, it is a suitable language in which to implement a high-level language. So, please, build something new on more VM. Give Larry Wall some clothes. Thank you.